Okay, so let's talk about last time's homework. Last time, because of word problem, okay, so I expect more questions probably, even though only 4 questions, right? So is there anyone want to ask a question about these 4, 5, 6, 8, and 9? Okay, so if not, I'm gonna go over 2 of them, okay, 6 and 9, okay? Number 6, it's pretty short, right? They give you two points already, only, right? Instead of telling you it's a Ferris wheel, right? So that one, that kind of question we didn't do, but then if you draw the graph, right? They give you the highest point, they give you the lowest point, you should be able to complete the whole graph. So it takes a little bit more of thinking, okay, to figure out other points. We're gonna go over that, okay? And number 9 will be similar to the one we did in class, the Ferris wheel. Okay, in class last time we didn't get to writing out the function, right? We just draw the graph. All right, so let's start with number 6. Okay, so you can take out your homework, even though you've already handed in, you can check your work. Okay, if you have a mistake, you can correct that and submit again. Okay, so let's have Angela, can you read out number 6 for us?
Sorry, which page is it on?
Page 65.
At a seaport, the water has a maximum depth of 22 meters at 2 a.m. After this maximum depth, the first minimum depth of 6 meters occurs at 8:30 a.m. Find the sinusoidal function to describe the depth of the water at any time with t.
Yeah, okay, thank you. So instead of the Ferris wheel, the height, right, we have depth. But I mentioned about maximum, minimum, even though the depth is talking about how low it goes, right? We're just gonna use maximum as the highest, right? And the minimum is the lowest, okay? So the whole y-axis is your depth, right? So let's just write down the keywords, right? We have a maximum depth is at maximum depth is 22 at 2 a.m. Minimum is 6 meters at 8:30 a.m. Okay, so let's draw the graph first, right? So it's talking about the time related to the depth, right? So we can change these two information into points, right? This is the same as having the time. Usually we put it as the x-axis. Okay, so 2 a.m. we can call that 2, right? 2 for the 2 hours after midnight. Okay, and the depth is 22. And then 8:30 will be 8.5 hours, right? So do not put 830, right? 8.30 is different, okay? Because we're talking about in hours, right? This part is minutes. So you have to change 30 minutes into hours. So you should use 8.5 hours, okay? And then the depth is 6. Right? Just making sure all the numbers are right. Okay. Right, so let's draw it out. So we have the time here, right? 0 means is 12 o'clock midnight, okay? And then we have maximum depth is at 2. Even though it says maximum, right? But it looks like the lowest, right? Because we're talking about depth. Okay. Oh, 22, yeah, 22. Number. So maximum depth 22. So deeper, right? So even though I put it at a higher place, right, actually it's talking about below the sea level, okay? And then minimum by 8.5. So let's say somewhere here. Okay, we have 6. Okay, let's put the scales, okay? So it's 10, 20, okay? So we have 20, 8.5 will be somewhere here. And 22 will be about here. 8.5 is 6. Okay, so we have 1 point here. 8.5 is at 6. And 2 a.m. Okay, what's going on? Sorry, I read the wrong number. 2 o'clock. Okay. 8.5 and 2 o'clock. 2 o'clock is 22. 8.5 is at 6. That took a while, right? Shouldn't take that long. Okay, 2 a.m., 22 meter, 8.5, right? That means 8:30 a.m. is 6 meter. Okay, so they only give you 2 points. And then from those 2 points, you want to figure out the ABCD. Okay, so let's quickly review what we did before, right? For the word problem. For example, like here, this one is the spring, right? So suppose you only have highest, right, and lowest point. From there, you still need 3 more points, right? You will need to get the middle point, right? The middle line. So middle point, you can use the average to find the middle point, middle place, okay? And then, because you already know how high it goes, right? How low it goes, so you already know the approximate location, okay? So let's get the middle point, okay? If they give you the highest and lowest, we need the average. So the average between the time, okay? So average of the 2 a.m. and 8.5 a.m., right? So we can do that. 8 plus 8.5 divided by 2. Okay, can I have you guys get the average points? Okay, and can you raise your hand if you found the average number between these 2 times? Two plus 8.5 divided by 2. Okay, Jenny, you can type it out, okay? You don't have a mic, you can type it out. Okay, 5.25, very good, okay? So 5.25. So that will give us this point. Okay, and then same thing, we're gonna do the average between the depth. okay, between 6 and 22. So 6 plus 22 divided by 2. So 6 plus 22 is 28. Divide by 2, so 14, right? Give us this one. So once you found the middle point, you are almost complete for the graph. Okay, so you can go follow the same way. It goes down, right? Goes out. Approximate, okay? Goes up. So all they need to give you is 1 point at the highest, 1 point at the lowest, right? Then you should be able to figure out the rest of the points. Okay, does it tell you which kind of function? Sinusoidal, right? So it could be a sine, could be a cosine. So let's find both, right? Because maybe some of you did a sine graph. Some of you did a cosine, right? So if it's a sine, okay, we'll use the one without reflection, will be easier. Okay, if they don't specify, right, always use the positive without reflection. So we can extend this graph, right? So it looks like a sine, so it goes to the left. Okay, and then let's draw the middle line. Right, that's our x-axis. Okay, so we need to get our amplitude, right? Amplitude. Amplitude, you could either use the formula or from the graph, right? Because this one, we don't have the grid, right? So it's faster with the formula, okay? We can use this one. Amplitude is maximum minus minimum divided by 2, okay? And B is 2 pi divided by period. Okay, CD is the new origin. Okay, so remember we're just using this. So amplitude is maximum minus minimum divided by 2. Okay, so you can check with your work. So please raise your hand if you have the amplitude for this one. Okay, Evan, do you know how to find the amplitude? Evan? -14 minus 6. What's the question mark? Okay, you need to take the highest minus the lowest. Okay, you can turn the mic. Okay, Evan. What's the highest value, Evan? Okay, Evan, can you turn on the mic? Your mic is also not working. Oh, okay. Okay. So everyone can hear. Okay, but it's okay. Highest is 22. Yeah, go on. Okay, 22 minus what? Yeah, go on. Okay, and then divided by 2. Because with the mic, I don't need to keep opening the chat, so it'll be easier. And also, the recording can hear it too. Okay, can you find the number? What's the amplitude then? Yeah, okay, so it will be 8. So 8 is referring to this part. Okay, from highest to the middle is 8, or from the lowest to the middle line, that's also 8. Okay, that's amplitude. All right, because when I marked your last homework 16, I still find many people have trouble going from the graph, okay, to the function. So make sure this is our last chance now, okay, to understand how to do this, right? Next part, so that's our A, okay? Amplitude is the A. So we found our A now. The next part is the B. B is 2 pi divided by the period. Okay, how long is our period here? Daniel?
13.
And how did you find that? How did you find the 13 to be our period? Daniel?
Like the maximum is 15. And then like the difference between 15 and 2 is 13, like in the middle.
15, where's the 15? Where did you get 15? I don't see 15 on the screen. How did you get 15?
I'm not sure.
Hmm?
I'm not sure because I got 15 on my graph, like at the on the like the time at the
Yeah,
maximum. I got
on
15.
time. Oh. You start with, because they give you 2 a.m., right? To be the starting point.
Yeah.
Yeah, and then it goes down to 8.5. Goes to the minimum at 8.5. So how long does it take from highest to lowest? From 2 o'clock to 8.5, how many hours is that?
6.5.
Yes, okay. That gap is 6.5. So this part from highest to lowest, that's not the whole period, right? It has to go back up to the highest again. Then we call that a whole period, right? So how long would that take again?
6.5.
Another 6.5, right? To come back, to complete the whole cycle, right? So from 8:30 a.m., right? 8.5 hours, you add another 6.5, what would that be?
15.
So this one you get 15, right? But then
Yeah.
we're talking about period, right? So that's where the 15 come from. But period is taking the amount of hours to go from 2 o'clock to 15. Okay.
Yeah, so you basically add 6.5 like together.
Yeah, okay.
Oh, okay.
Yeah, okay. So what's 6.5 add a 6.5?
13.
13, okay. So that's where the 13 comes from, and that's where the 15 comes from. Okay, so using just maximum and minimum, you could figure out the amplitude, you could figure out the period, okay? Because from maximum to minimum, it's like one way, right? You have to go return, right? You go down, you have to come back up to call that a complete trip, right? So only half the trip if you go from maximum to minimum. So we found out A, we found out B, okay? Now the CD just depends on whether you want the sine or cosine. Okay, if you want the sine graph, remember the sine graph. Okay, we'll write it here. If we want the answer in sine, then the graph should start from the middle line, right? Should start from 0, 0, like that. So for that to happen, we place our axis over here, right? I'll use the green. Okay, if I want to use sine. So this will be our origin. Okay, if you want to use cosine, I think cosine will be easier because cosine, they already give you the highest, right? If it's a cosine graph. Then you have to start with the highest point. Okay, they give you the highest point, which is over here, right? Maximum. So if it's in a test situation, right, you would choose the cosine, will be faster. Okay. All right, so origin will be here. Because you don't have the origin for the sine, right? You need to figure that out by yourself. Okay. So let's take a look here, right? So let's start with the cosine then, since cosine is easier, okay? For if the origin is there for cosine, what's the CD then? Okay, where's the new origin? Can you raise your hand if you have the origin for cosine graph? Okay, check your answer on your homework, right? What did you put down for your CD? Okay, Waylon, did you have an answer for the origin? So Waylon, what's yours? What's your origin number?
2 and 22.
2 and 22. 22 is the highest. You don't use the highest as your origin. You see the circle, the green circle? Not this one. Okay. You see the green circle I put on the screen?
Yeah.
That one's the origin, okay? Not the highest point. 2 and 22, that's the highest point on the cosine, right? But then the origin, you have to use the x-axis and y-axis, the new x and y-axis where they cross.
Oh, okay.
So where is that?
214.
Yeah, okay. You have to choose the middle point, okay? Not the highest point. So 214. Okay, so remember the origin is always on the middle line, okay? It just happened that for the sine graph, it's also on the graph, on the sine graph. But for if it's a cosine, it's below the highest point, okay, or above the lowest point. Okay, so for cosine, we're done, right? We got our A, B, C, D, right? A, B are the same, okay? So our function is, we shouldn't use Y, okay? Because this one is word problem. So for depth, we'll use D, okay? So D equals to A, right? A is 8, cosine, B, and then C, D. Okay, so that's our answer for cosine. Now, what if they say you have to write a sine function, right? So you still need to know how to get that. So if it's a sine function, then our origin will be shifted, okay? Will be shifted to here. Okay, the one on the left side. So you need to figure that out, right? What's the x coordinate for that place? Okay, is there anyone use the sine as your answer? Doesn't matter, okay? Everyone try it, right? Even if you did a cosine, right? So please find the origin for sine function, okay? And once you got that, you can raise your hand. Okay, let's get a CD on the left side. Okay, you should always practice, okay? Think about if it's a sine, where do I put the origin? If it's a cosine, where's the origin? Okay, if you have this origin for sine, please raise your hand. Okay, Eric, what did you get for origin? Negative 1.5 and what? Hmm? I can hear you. Can you say it again?
Is it 14?
Your mic is not very clear. Can you try again? Or you type it out. Yeah. Let me see. Negative 1.25 and 14. Okay. Negative 1.25 and 14. How about you, Nick? What'd you get?
I got 0, 14.
Okay, if it's 0 and 14 will be up here though. Will be this one. Right? That's not where
Oh.
okay, we are looking for the green circle. Okay, I circle the green. Circle the red dot with the green, right? We're looking for that place. It's on the left side, so it should be negative something. Okay, how about you, Susan? What do you have?
Negative 2, 14.
Negative 2, 14. Okay. All right. Marcus, what do you think?
I'll put negative 1.25 and 14.
Okay. All right, and so Marcus, can you tell us how you found the negative 1.25?
I minus like 3 point, I forgot, like it's like 6.5 and like kind of like half that, and then I minused it by 2.
Okay, very good. And minus from 2. Okay, so the 6.5 is the gap between highest and lowest, right? Between the 2 and 8.5. So between those two, right, if we cut in half, that's like telling us the size of space. Okay, remember we have the SOS, okay? Size of space, 3.25. It's always 3.25 in between each important point, right? It takes 4 size of space to complete the whole period. So if we want to get the point on the left side, we need 1 more size of space, right? Starting from 2, I need to walk 3.25 to the left. Okay, so you need to subtract 3.25 to get to the left point. Okay, so 2 minus 3.25. That gives you the negative 1.25. Okay, that's where the negative 1.25 comes from. So a little bit more challenging, right? You need to think about size of space. But basically, if you have a good graph, right, you can tell that you need to use size of space to get each gap, right? So this one is from 2 minus 3.25. Okay, so there you go. Okay, we got our CD, so we finish our function. 8 sine 2 pi over 13, t for the time, right? Minus negative 1.25, so it should become plus. Okay. Remember the form is always minus c, so minus a negative plus 14. Okay, so make sure you need to know how to do more than one way, right? Either the sine or cosine, because you can never expect the on the test what they ask you to do, right? Sometimes they will say sine, please write out a sine function, please write out a cosine function. Okay, you need to know how to figure both ways. Even like with a reflection, where would you put it, right? Without reflection, where do you put the origin? Okay, so let's go over one more and then we conclude this chapter. Okay, so no more graphing, okay, for the trick. So let's look at number 9. Is it number 9? What was it?
Yes.
Okay, all right. Okay, so this is a Ferris wheel, right? Has a diameter of 60 meters. Center is 32 meters above the ground. Rotates once, right? One turn, right? Once every 40 seconds. So that's right away our period. You don't need to figure out the period. That's good, right? Gary gets on the Ferris wheel at its lowest point. So that's the starting point. And then start to rotate, right? So if it gets on at the lowest point, the only way to go is to go up, right? And find the equation of the passenger. So that means Gary, right? Gary's height above the ground, okay, as function of time, right? Meaning the time is the other variable, right? H is the height. Okay, and then determine the time when Gary will be 35 meters. So is it part A or part B that you have trouble?
Part B.
Part B, okay, so you found the function for that one.
Yes.
Okay, can you tell us the function that you got then?
So I got h of t is equal to 30 times sine 2 pi over 40 t plus 2.
30 times sine, and then what?
2 pi over 40
2 pi over 40, and then
t plus 2.
plus 2.
No, not like plus 2's like outside the brackets.
Oh, outside. Okay. T plus 2. Like that.
Yes.
Okay. So let's check if this is correct. Okay. Do we have any other answer, right? From other people? Because there are many ways, right? Maybe some of you did the cosine, some of you did the sine, right? You could check your answer because what you get for the function, right? It will affect your answer for part B. Does anyone want to check your answer? Can you let me know? Just turn on the mic. Tell me what you got. If you got something different,
Jason,
yeah.
I actually got it's not sine, it's cosine.
Oh, you did cosine. Okay.
Yeah.
Okay. Is there anyone have a different answer than this one? Doesn't mean it's wrong. Okay. It just means you use a different origin. I don't think and everyone got the same one, right? Claire, what's the answer that you got?
I got the same thing.
Exact the same?
Yes.
Oh, wow, what a coincidence. Okay. Philip?
Can I share?
Yeah,
Oh,
Philip.
perfect. I got negative 30 and plus 32.
Negative 30 and also cosine.
Yeah.
Okay, 40t plus 32. Okay. So the t, you can put brackets around it or not, doesn't matter because nothing add or subtract. Or you can put a big bracket like this to show that the 2 is outside. Okay, the 32 is outside. Okay, so we have negative at the front instead. Okay. Anyone else? Anyone use the sign as your answer? I'm gonna practice both, okay? Marcus, what about you? What's the answer you got?
Oh, I'm still working on it. I didn't finish it because I was kind of confused on how to do the homework.
Okay, so now you know how to do it?
Yeah, I'm doing it now.
Okay. Sophie?
I got 30 sine bracket pi over 20 and bracket t minus 10 close brackets and then plus 32.
Okay, so now we have sine and cosine. Okay, let's do both. Okay, see which one is okay, right? Usually for sine and cosine, right, we want to choose the origin closest to the original, right? Closest to the y-axis. Otherwise, you can choose as far as you can, right? Then too many answers. If we choose the closest one, everyone should get the same answer, right? Either sine or cosine, that will be the only difference. Anyone else want to chip in, right? Adding your answers. Gonna grab this to the side, okay? Okay, so we need to have a graph first, right? A proper graph. So time, right? So it tells you the center is 32 above the ground, okay? So let's put 32. diameter is 60. Right? Diameter is 60. That means the radius is 30. Right? So from the center, go up by 30. So that should give you 62. Go down by 30. That should give you 2. Okay. This part is your radius. Together is your diameter. Right? And that already tells you the amplitude. So this one is easier than number 6, right? Number 6, they only give you 2 points. This one, they give you quite a lot of points. They give you the middle point, give you highest, give you the lowest. Even better, they give you the period, right? So rotate once every 40 seconds. A very nice number, right? So from 0 seconds to 40 seconds, it makes 1 turn. And that can tell us the size of space as well, right? This is your period. So what is the size of space then, Nick? If period is 40, right, how do you find this SOS? Are you there, Nick?
Hi, can you hear me?
Yeah, no,
So-
now I can, yeah.
Okay,
Okay.
divide by 4.
Yeah, what is it then?
10.
10, very good, okay. So very nice number there, right? So middle is 20, it's always go by 10, right? 10, 20, 30, 40, and completes the period. Now the person gets on at lowest point, right? So we know that we have to start from here, right? And then start to rotate, so that person goes up. Keep turning, right? Go to the highest point after 20 seconds. Okay, that's a pretty fast, right? Ferris wheel. Only 40 seconds in 1 turn. Oh, that's no fun. Right? Probably a smaller one, okay? Like the one on Lansdowne, right? A smaller Ferris wheel. Remember, do not connect with like a triangle straight line, okay? You have to make it curve. Okay. There you go. Way faster, right? They give you a lot of information to start, right? So now you got a graph, you have the amplitude already, right? So you have amplitude is 30, and the B is 2 pi divided by our period, which is 40. If you like, you can simplify it into pi over 20. Okay, it's better to simplify. Now for CD. Okay, so CD, let's draw the x-axis, the new x-axis. If it's cosine, okay, since we have 2 answers for cosine, right? If it's cosine, the one that's closest to the y-axis, you can choose this one. Then that's our origin. Okay, but if you choose that one because it crosses the lowest point, that means we have a reflection, okay? So it's a cosine with a reflection. So origin, right, if it's a cosine, then the origin will be 0.32, okay? Instead of 0.2. So remember, for cosine, your origin is not on the graph, okay? Not on the graph. That's why I say you have to find a new origin, not the starting point. Okay, your starting point is not always your new origin. You have to use the cross, okay? The cross between the x and y axis. Okay, so Nick, where is the new origin for cosine?
0.32.
Yeah, okay, so CD should be 0.32. Okay, and remember for this one, we need to have negative for the amplitude because the reflection. So H of T, right, equals to 30, but we need a negative cosine pi over 20 and T, right? Because there's no, C is 0, right? So just T minus 0, I can just write T and then plus 32. Okay, and then if it's a sine, sine will be starting from here. If you use sine, so origin will be this one, right? Because after that, it looks like a sine function, right? Look at the yellow highlighted. Looks like a sine. Okay, so the CD, right, based on the graph is at 1032. So looks like we have the right answer. Okay, so this one. Okay, so sine is, it will look like that. Cosine, it will look like that. So either way, okay, doesn't matter if you do sine or cosine, right? Because it didn't specify. Okay, find an equation. Okay, so now we have part B. Okay, let's erase this. Let's do part B. Let's try to fit part B here. Okay, it's asking what's the time, right? When's the first time? Find the time when Gary is 35 meters. Okay, based on our graph, 35 meters is talking about the height. That height is somewhere about here. So if we make it across, right, touch the graph, so it should be somewhere here on the graph, right? The Gary, right, the passenger is 30 meters above. And the first time that it happens, if you trace down to see the time, then it should be this place. That's what we are looking for. So we could expect our answer to be around 11 seconds, 12 seconds, something like that, okay? Higher than 10 seconds, okay? Longer than 10 seconds. So 30, just remember the 35, the number they give you is for the height, right? So you do not put the 35 into T, right? You first need to recognize that. So let's choose, we can use either one, either equation, okay? Let's use the cosine because cosine looks simpler, right? Shorter, right? It doesn't have the minus 10. So put 35 in. But it will be the same way, okay? If you use the sine. So put 35 equals to negative 30 cosine 2 pi over 40 t plus 32. So our goal is to find time. Okay, Nick, do you have any questions so far?
Nope.
Okay, so we want to isolate time. So what you can do is pretend this part is your variable. You want to solve for that variable first, okay? Because 2 pi over 40t looks very confusing. You just block it, okay? Treat that as a big X, okay? You want to isolate X. So you're gonna start by moving things over. What's the first thing we should move over?
32.
Yeah, very good. Okay, so 32 goes over. So the left side becomes,
30, I mean 3.
yeah, it will become 3, right? 35 minus 32, so it'll be 3 equal to negative 30 cosine x. Okay, we'll just call that x. And then what's the next thing you get rid of?
Negative 30.
Yeah, how do we do that?
So divide both sides by negative 30.
Very good. So on the left side will become,
Negative 1/10.
okay, negative 1/10, or let's put in decimal, negative,
0.1.
yeah, negative 0.1 is cosine of whatever that's inside. Okay, so
Okay.
cosine something equals to negative 0.1. How do we find the something?
Is it like inverse cosine?
Very good. Yeah. So it's like finding angle, right? We learned this before we started the graphing, right? So we can, to get the x, or x will equal to inverse of negative 0.1. Can you tell us what you got? Make sure you are in radian mode, okay?
Okay. Jason, I can't hear you.
Yeah, I didn't say anything. I'm waiting for your answer.
Oh,
What's
could you
cosine
could you
inverse?
repeat the question?
Can you put it into your calculator, what's the cosine inverse of negative 0.1?
Um, 95.7.
I think that will be, oh, let me check. Can anyone else confirm that? Okay. One 1.47. We have a 1.47. Anyone else? I'm looking for. Oh, cosine inverse of negative 0.1. Make sure you're in radian mode. Right?
Oh, then 1.67.
1.67. Yeah, okay, 1.67. Good. Okay, so that is for x only, right? Almost there. Let me erase that. And remember, we use x to represent whatever that's inside the cosine, right? So now we need to open it up and take a look at it, right? So the x represents 2 pi over 40 t, right? That part equals to 1.67. So how do we find the t? Nick?
So you have to divide by 2 pi over 40.
That's right, okay? So be careful when you do the dividing. 1.67 divided by, if you are using your calculator, make sure you have a bracket, okay? Bracket 2 pi over 40. You want to divide by the whole thing, okay? Did you try that? And let me know what you got.
10.63.
Okay, if you round it to the 10th,
10.6.
okay. Let me double check. Yeah. Okay, so if you round it, it will be about 10.6. And that will be the time, right? So it makes sense with our graph, right? A little bit after 10 seconds, okay?
Okay.
10.6. So you can answer in in a short sentence, you can say after 10.6 seconds, okay?
Okay.
Yeah.
Okay. Thank you.
Yeah, you're welcome. Okay, so this should conclude our graphing. Okay, this is a very important chapter. Even like later when you are learning calculus, we still need to sometimes have to talk about sine graph, cosine graph. Okay, how to find angles, right? Exact values. Those little things keeps popping up. Okay, so make sure. Yeah, keep the notes, right? Later on, if you are learning more advanced math, right, you can always come back and review. Okay, so say goodbye to trig function. We still have trig, no, okay? We're not totally away yet. We have part 2, but part 2 is much easier, okay? A lot shorter. So no more graph, okay, in part 2. So how about let's take a break, okay? And then after the break, we'll start on part 2, okay? We just have 2 pages to go over, and they're pretty easy, okay? But you can use this time to review this page, okay? Because part 2 needs this. So go back and look at your notes. Think about how we do this one. Page 41, okay? So go to your book, right? Take a look at page 41, find exact value, okay? Use this break to just quickly go over the question that we did in class. Draw angle, reference angle, side ratio, check sign, okay? Angles on axis, okay? What does that mean, right? Go over a few questions on your own. So then when we are doing the part 2, okay, it will be easier for you, right? And we'll come back at 10:45 then, all right?